In this lecture, we learn how to create geometry using ICEM CFD. Then we learn how to create meshing based on blocking strategy. And then we learn how to create mesh, how to give boundary condition, how to check mesh quality, then how to export the mesh file in different format. Here option is the file. In here we can save the project, whatever you want name we can save project. Always try to give in new folder like diffuser, conversion and diffuser, conversion, converge and diffuser section. Always create separate folder, and in separate folder save all the file. Here whatever you create the name, it will be saved here. There are some important options. Here you can uh, import the model. We can import the model in a different format, IGS format, step file. We can also save, because these two are common use. We can import CATIA file, blade generator file, ANSYS format, SolidWorks file. We can also import. If we don't have file for the geometry creation, then we can create the model here. Here I will create a model like this way: conversion section and divergence section. I will take this model. It has 10-meter width, and this way it has 10-meter section, conical section, 10-meter divergence section, and here I take as a 2.5-meter width. Then here 10-meter, and this is the inlet. This I will take inlet this side, and this is the outlet. And here this is the conical section or throat. We want to model this problem using ICEM CFD. What we can do? First, create a point. First, create a point. Such a way that we can create the model. Take this one uh, as a 5. Create this is as a point. This point will be created. Then also create a -5 point. Then also create a point -5, and then here you can also create a point here. -5. If you want to delete point, you can also delete this point. Select it, delete it. We can delete the point. And then we can create a model here. Here we can create a point here 0 to 10. Let's see the how this point is there. Then these points are created. Then these points are created. Then other first point is 0, 0. Once these points are created, then create a curve. Click first point, last point, click. Then middle click, then operation or then click on first point, second point, click. Second first point, second point, middle click. First point, then click on second point, then twice of middle click, then this curve will be created. See, this curve will be created. Then I have to also create a middle section. Then how can I create middle section? Which is located at z is equal to 10. Then here we can select the section y at this is a 7.5. Here we can select the other 2.5. Just it will be at the center here. Center means you have to create here small section like here like with this one. Then here we can select here. It will be x. It will be at the center here. This is 5 to this is how 2.5 means this are 2.5 to 7.5. You just we can create this point here. And then we also create here the point at the this is 7.5. This we can also create the second point here. Then we can also create this point here. Just we created this point. They join this curve. Click here because this option is here to create a curve. Then click on first point, second point, the line will be created. This use a left mouse command. A left mouse select, then followed by middle click. Then middle click. Just click here. First point, second point, middle click. 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 Then curve will be created. Then second is a create the surface. Yes, select the first surface, second surface, directly surface will be created. Here we can see surface will be created. Here click here first surface because we are creating the curve using the two surface. because here we are creating curve using two surface. First curve, second surface is created. Then we want surface here also. Then we can move this body, copy in y direction at 20. Then this curve will be created. Then we have to this copy this curve. This I have to copy at surface here. That means here copy is created. This part is copied to here. Then create the surface using two curve, first curve, second curve. First curve, first curve, second curve. Curve is created. First curve, second curve. This way we can create the surface using two curve point formula. First curve, second curve. First curve, second curve. This way you can also create a surface. This way you can create a curve. You can create a curve. This we can create curve here first and second. This way we have created a curve duct. This way we have created duct. We have to create this using ICEM CFD. After creation of geometry, the next option is click on blocking. This is option is blocking after the geometry. Then edit mesh. Then output option is there. Here you have to click on the 3D blocking because this is a 3D geometry. Because this is a 3D geometry, X, Y, and Z direction. Because of 3D geometry, you have to select 3D blocking. Here select on apply, click on here, apply, then 3D block will be created. 3D block, this is the imaginary, this block created for the machine. Its color is black because this is not associated. This is black block because this is a not associated, because no association, hence it is looking as a black color. Here you can see here block is created. Here I can hide surfaces. Before giving block, we can also give a name, and you can see here part. This a part is there. This is the geometry what I created here. This is geometry, and this is the solid block. Solid block. This is the fluid domain. This OpenFOAM. This is a supporting file, supporting mesh file, and it should be empty. Then the next step is a modification in block as per geometry. Here is the splitting of the block. Here I can split here block. I can create this edge. We can select here selected point at this. You can select this edge. Here we can create a split block. Here we can say option is there. We can select a different block here. Here the block is splitted at this point. Then you can see there are two blocks are there. Block means this is the volume. This block indicate that means these are the fluid volumes are there. It can be solid volume unless we give name. Here I can give name as a fluid, air, done. The next job is association. Then this is the option is the for association. This option is there here for the modification of the vertices. This what are vertices are there? This block, this option are there. We can use this option for the complex geometry, but here we don't need to for need much changes in merging of vertices. This option is there that we can use if required. This is the option is there for the edit of the block. You can merge two block, you can merge face, you can do modification in block. Then next option is association. In association, this association of the this node with respect to this point. The second is line to edge. We can associate some edge to the see this edge to the this line or block. You can associate this edge to the line of the geometry. Then this option is the association of the point with respect to surface. This is option is for de-association. This is auto association. But here with edge to the curve association. First associate this curve with respect to this edge. We can hide this curve. You can see this is a color is changed here. We can see here color is changed. That means this is associated, and this is black. That means this is not associated. We have to associate this curve. Click here, edge, then middle click, then click on edge, middle click. Similarly here, click left click, then middle click, and then select the curve, then middle click. Similarly for the all cases, first select the edge, middle click, then select the curve using the left mouse, then middle click. You have to use option. First is the select the edge using the left mouse, using a left mouse operation, then middle click, then select the curve. Select curve using the again left, using a left mouse, and then middle click. then middle click. Select using left mouse for the edge. Then select the curve using left mouse, then middle click. Then you have to oscillate again this one. If something went wrong, you can make here undo. Here option is the show association. That means this is the wrongly associated. That means this is the wrongly associated. We can associate here properly. That means association is complete. You can see this is the color is changed. Color change, that means it is a green yellow. That means all edges are associated. That means it's okay. Then association is okay. Then we can hide this block edge, and then you can give the sizing. Here is option is there, blocking. You click on this option, and there here is option is the middle option for the sizing, and you can select the curve here. You can select this curve here. Here option is there, copy parameter. Don't forget, click on here copy parameter, so that the meshing parameter will be copied to the all parallel edges. Here I can use a 50 mesh size. Here mesh option is there. The advantage of the ICEM CFD is that we can select the meshing parameter whatever we want. We can use the spline concept. If you want to, you can select here exponential parabolic end. You can modify the curve as per you need, then apply. Similarly here, you can select this 15. We can take spline concept, parabolic end. Just we shift here to make uh, linear variation of the, that means here is smoothly variation of the node point. Then apply it. Then we can select this one as a 50 node point. We can take spline, we can take linear variation. This is the first point. Please note that this is the first point because this is the starting point, this is the end point. This will be variation and this curve direction. This is because this is the curve direction. That means here will be coarse mesh and here will be fine mesh. I want fine mesh only here because here velocity is very high. Because here velocity is very high, this I want to fine mesh here. Here I want to fine mesh here and here to be coarse mesh. That will be created. Here apply. Here is also same thing. We can select the 50. We can select the spline concept, ramp. I want fine here. I want course at the end. Here, here is similarly. I want to find here, course here. Please note this will be applied here. And here course will be there. You can select whatever you want to the variation. Here mesh is given, here is also there. That means you have given the mesh all the sizes. You can save the project. Here ANSYS project is saved here. Project file, FBC file, ATR file. You can check the whatever file are saved here. See these files are saved. And this block file is saved. Project file and tin file. Tin file is the geometry file. Please know this is a geometry file. Then here click recomport. Then you also show the pre-mesh information. That means how much mesh size will be created here. That means 2,35,000 mesh will be created. Then convert to the unstructured mesh. This way mesh structure mesh is created. We get uniform variation in mesh size. Then next option is we can also check the mesh. Here option is check mesh. Here you can check the aspect ratio. Here maximum aspect ratio is a 5. You can also check the angle, skewness, distortion, mesh quality. You can also check. Here you can also check the quality if you want. This mesh quality is okay, 0.95. We can also check the and this is angle. This we can check angle. Means all angle are below 70 degrees. That means mesh quality is good. That means mesh quality is good. The next option, once name is given here, next mesh quality option is here. Check the mesh. Here option is here option check mesh. This option is there here. Check mesh. That means there are no uncovered faces. Uncovered faces should not be there. That means mesh are okay. That mesh is okay to export. The next steps is to give the boundary condition. This I can hide this mesh. The faces have to give name. Here I have to give name. With a right click, create part. Select this surface. Give name. This is as inlet. is immediately inlet will be created. See here, whatever inlet will be created here. Similarly here I use outlet, click here, then made a click, outlet will be created here. Similarly I create a wireframe here. I can hide this surface is there here. Geometry and this piece I can hide here, inlet, outlet. Similarly I can give name here. This is a throat. This is the interior. I will click here. It will be created as throat. Then I create wall. This one. If you want to add this one, we can select here, right click, add to part this one. Then this space will be created. This part will be added, and it shows a different name. Right click, add to part. This will be added. That means this is wall, and similarly we can select them. Right click, add to name part, wall 2. We can create add to part. Select using left mouse and then middle click. That means all names should be given. This is the inlet, the outlet, and this is wall, and this is fluid domain. Whatever it shows is a block, that means it is a fluid domain. That means mesh is okay. Here we can show the mesh. That mesh is fine. Then here select for the output. Click here, then click here, then select the ANSYS FLUENT, then apply. And please save this file. And then accept boundary condition. Save file, because we have already saved file. Hence we don't want to project file. We can also save yes. You can select X mesh, because we create X unstructured mesh, and export for the 3D. This is 3D conversion, diversion section. Just done. That means ANSYS FLUENT file has been saved successfully. Name is 3D cone divergence. This is name of file. If it is done, that means ICEM CFD mesh is created. Then you can check this file. This is a mesh file is saved. This is unstructured mesh file created using ICEM CFD. Please find this unstructured file. These are blocking file saved. This is a recent blocking file. This is a project file, this is a geometry file, this is a unstructured file, this is a supporting file. You can check in FLUENT. Then file, read, mesh file, 3D diversion section. Then first check the size is 2,35,000. Similar same size was showed here. ICEM CFD pre-mesh information 2,60,000. Here you can also check the mesh quality. Here mesh quality is 94.94. Similarly, what mesh quality shown by ICEM CFD? Here we can also check the quality. Quality was 94%, because this is a mesh quality is created because of the this 94%. That means mesh is okay. Then you can give boundary condition. You can also check the faces. That means this boundary condition has not selected. That means you have to check whether this condition are okay or not. You can open this project again. We can make this orphan blank. You can see this is a mesh. Pre-mesh quality also check. We want to currently recompute, yes. The block, we can hide this mesh. Then here is option is output, ANSYS plant. The accept option is there. Boundary condition. These names are there. Pre-mesh option is there, or you can make blank. This is a recompute. Convert to the unstructured mesh. We want to replace. You can make blank. And this is a blocks are there. You can see this blocks. This is a blank. The inlet there, and we can export. The ANSYS fluent form, apply, accept, when to save no. Then you can select this file 3D format. then 3D nozzle, then done. Then we can mesh read file. Here we can see the all boundary condition has been read properly. This inlet, wall 1, outlet. But here you may surprise why this middle surface is not looking here. Middle surface is not looking here. The reason is that because it has same fluid on the both side. Then to avoid it, then I can create the separate fluid zone. Create, this is the fluid 2. If I select this one as a fluid 2, fluid, and this is the fluid air. Then we can see this is throat will be visible. Then I recompose, convert to unstructured mesh, replace. This is we can see the mesh. This meshing we can see here. Then save output. Then apply, accept, save current file now. It is already saved. Then you can see FLUENT shading nozzle 2. Then done. This is inlet and this is outlet. And then read the mesh file. Then you can see here this throat is appeared that and two fluid zones are reflected here. Display here, and here throat is there. See here throat is here shown by different color. You can see the faces here. The throat is here. This way we can split the block into two parts. This one separately. This is one block. This is one. This is a fluid 2. This is a fluid air, and this is the interior. And this way we can use ICEM CFD for creation of the structure mesh.
Thank you for attending this lecture. For more information about CFD analysis of any problem using ANSYS, FLUENT and OpenFOAM, you can visit website www.com CFD Flow Engineering. It covers most of important topic for engineers, scientists related to the CFD and flow engineering, and also covers topic for flow technology. Thank you for attending this lecture. God bless you.